learning targets, we're really talking about angles, and we're going to be dealing a lot with angles. Angles are not anything new to you. You know what an angle is. So an angle is made up of two rays that meet at a vertex. That's not new information to anyone. However, in this class specifically, we're going to be really focusing, all the definitions have the terms initial side and terminal side in them. Initial side meaning where the angle starts, and terminal side meaning where the angle ends. And you'll be able to determine that because there will always, well, should always be an arrow drawn in it showing which way the angle is opening. Okay, so you can see that it's starting here, and there's an arrow that goes up here, so it ends at that second ray. So initial side to terminal side. Okay, it's important information. Vertex is right here. Right. Initial side, the initial side is this ray, and the terminal side is this ray. Okay. And all the angle stuff we're doing today, and anytime pretty much in this chapter, in the next few, we're always basing our angles on the coordinate plane. Okay? Almost always our angles are going to start with their vertex at the origin and their initial side on the positive x-axis. Almost always. Okay? In relation to the coordinate plane, then, you guys all know what a right angle looks like, right? 90 degrees. Well, so then in relation to the coordinate plane, a 90-degree angle would go from here to here. That was supposed to be straight, but it wasn't, so I apologize. That would be 90 degrees. Right? You would keep going around, and you could have an angle here. That would be 180 degrees. And you could keep going around, and that would be 270 degrees. Right? And you could keep going around and start where you started, and that would be 360 degrees. Okay? So it's important to notice the spirals I'm making. Okay? Because if I just draw this, that's what a 360-degree angle looks like. It doesn't look like that unless you put in the spiral. Right? Because the initial side and the terminal side are in the same spot. Okay? You also need to understand in this section that you can make angle measures that are past 360 degrees. Okay? If I wanted to make an angle that was 720 degrees, well, then that means I would start and go all the way around to 360, and then go all the way around again to get to 720. That's what the angle looks like, that spiral, right? Because the initial side and that terminal side are in the same spot, but the spiral indicates how many times we're going around. Okay, so make sure that you're looking to what the angle, how the angle is being made with that arrow. Does that make sense? Okay. It's important also to note that if you're rotating counterclockwise, that you have a positive angle. If you rotate clockwise, you have a negative angle. Okay, that's going to be very important what we're doing in like learning target 2, and I'll remind you that again. But counterclockwise is positive, and clockwise is negative. Okay, so this right here in this image that I have right here, this could be a, it's not exactly, but this could be a 220-degree angle, right? The blue one could be 220 degrees. But this other one could be negative 140 degrees. Right? They look at the same initial side, the same terminal side, but because of the way I drew the angle, it made it in different measures. Does that make sense? Okay, so make sure you're looking at those directions. Those are important. All right, another definition before we get started. Standard position just means what we've been talking about. The vertex is at the origin, and the initial side is on the positive x-axis. That's what standard position means. Vertex is at the origin, and the initial side is on the positive x-axis. That's all that means. Most of the definitions and things we'll do today say at some point an angle in standard position. That's all it means. Vertex is at the origin, initial side, positive x-axis. All right. Another definition really quick. A quadrantal angle It's just an angle and standard position, but both the initial and terminal side are on an axis. That's all that means. Right? So the sides are on axes somewhere. Does that make sense? Okay. We won't use that term as much, but it comes up. The quadrantal angle is just when the sides, initial and terminal, are on an axis. You have to have like 90, 180, 270, 360. Negative versions of those. Okay. Questions about those terms? Alrighty then. Learning target 1 then says to convert decimal degree measures to degrees, minutes, and seconds, and vice versa. Degrees, minutes, and seconds are an outdated way of measuring things that aren't used in very many ways, and I wouldn't even cover it. The problem is, throughout the next few chapters, every once in a while an angle will come up in the book, like probably once or twice a section, and instead of just having a triangle with a 30-degree angle, it'll say it's 30 degrees and 25 minutes. Well, that's not very helpful if you don't know what that means. All right, so I'm going to cover it simply to make sure we're not confused. But I'm going to show you how to use your calculator to make sure you can convert them all to decimals so you don't have to worry about it. Okay? You guys have all measured angles in degrees before. That's not new. There's actually other ways to measure angles we'll talk about in the next unit. Okay, but right now we're still focusing on degrees. So if you have a degree, you can split that up into 60 equal parts known as minutes. And you can split the minutes up to 60 equal parts known as seconds, just like a clock. Right, it's nothing fancy. So I'm going to show you what I mean with the first example by hand. And then we're going to go back, and I'll show you how to do it in the calculator, because you want to do these by hand. I just want you to know how to convert them so you can use them in class and other sections. All right? So I have 34.95 degrees, and I want that to be in degrees, minutes, and seconds. Well, that means I have 34 degrees. Everything in front of the decimal point is your degrees. Well, that 0.95 could be written in degrees, minutes. It could be written as minutes and seconds. So I would take that 0.95 and multiply by 60. Or you don't do the 0.95 times 60, you're showing how many of those parts are minutes. So 0.95 times 60, and you get 57. So I have 34 degrees and 57 minutes, which we denote by an apostrophe. If it had said 57.5, then that extra decimal part we'd multiply by another 60 to get our seconds. So we would have 34 degrees, 57 minutes, 30 seconds. In this case, it came out even, so we have 0 seconds. On the flip of that, if it gives you degrees, minutes, and seconds, you can convert it back by dividing the seconds by 60, and then dividing the minutes by 60, and combining the decimals to get back to a decimal. We're not going to do them by hand, so no worries. If I lost you, there's no worries. We're going to use the angle menu on your calculator instead. So, if you have your graphing calculator, go ahead and type in 34.95. And if you go to second apps, that's the angle menu. And you'll see the degree symbol and the minute symbol there in 1 and 2. You go to number 4, it says arrow DMS. That means you're converting to degrees, minutes, and seconds. We want to take the decimal and convert it to degrees, minutes, and seconds. So we scroll down to 4 or click 4. And then click enter. And it'll tell you 34 degrees and 57 minutes and 0 seconds. So it does it for you. So go ahead and do the second example real fast so you can familiarize yourself with where to go. And hopefully you got negative 72 degrees, 46 minutes, and 30 seconds. Yes. Okay. We often are able to do the opposite. That's what we mostly use it for. Is we have degrees, minutes, and seconds. We need to get it back into decimal form so we can do something with it. Okay? So, similar ideas. Type in negative 128. Then go to the angle menu again, second apps. And then hit enter when you see the degree symbol, number 1. type in 30, go back to the angle menu, second apps, go down to number 2 to use the minute symbol. There is not a second symbol in the angle menu. You can use a second symbol by using the quotations on the alpha part. So like all of your letters. So go to alpha, and the quotations are above the plus sign. So then you hit enter, and it gives you the decimal. So negative 128.51. It says round to the nearest thousandth, so 513 degrees. So go ahead and do the second one just to familiarize yourself with those buttons. So those directions are at the bottom of your note sheet. But again, second apps is where the angle menu is, and then you can use the quotations above the plus sign for the second symbol. So hopefully you got 29.102 degrees. It was 1017, but it said round to near south. Any questions about that? All right, any questions? Awesome. Again, well, that'll come up in various sections. Just on the homework, it'll say, instead of giving you a triangle with 40.5 degrees, it'll give you in degrees, minutes, and seconds. So just so you know, so you can use it. All right? Excellent. Learning target 2. We're finding the number of degrees in a given number of rotations. So how many degrees is in one rotation? It's not a trick question.
360.
360. And we talked about earlier, clockwise means what? Positive or negative?
It is
Clockwise means negative, and counterclockwise is positive. So for the first example, it says give the angle measure represented by each rotation. It says 2 rotations clockwise. If I was going to draw that, I would go around once and twice. So that would be negative, because it's clockwise, and it's just 2 times 360, right? So it's negative 720 degrees. Questions about that? It's 2 rotations clockwise, so clockwise means negative, and rotations are 360 degrees, so it's just 2 times 360. So it's negative 720.
Oh, it looks like it's decimal.
Sorry, it's 2 times 360. So on the second one, 4.5 rotations counterclockwise. 1, 2, 3, 4.5. Then you have 4.5 times 360, and it's counterclockwise, so it's positive. That's 1,620 degrees. That's learning target 2 in its entirety. I know your mind is blown, but I'll tell you the most complicated thing all year. So, questions about learning target 2? All you're doing is multiplying by 360. No. All right, questions about learning target 2? All right. 2 angles in standard position are called coterminal. They're the same terminal side. So since angles differing in degree measured by multiples of 360 are equivalent, every angle has infinitely many coterminal angles. So in this picture I have drawn, I have a 45-degree angle, but then if I go all the way around again, I have a 405-degree angle, right? And if I keep going around, I'm going to keep adding 360, and all of those angles look the same if you took the spiral off, right? So those are all coterminal. So if you have some angle, alpha is what our book uses as an angle measure. So alpha could be any angle. If alpha is the degree measure of an angle, then all angles measuring alpha plus 360 times k, where k is an integer, are coterminal. That makes sense. So you keep adding or subtracting 360 over and over again, you're going to keep ending up with the same terminal side over and over again. So we're in target 3. Identify angles that are coterminal with a given angle. So the first section says identify all angles that are coterminal with each angle. We just talked about there's infinitely many, so I cannot actually list out all. I just need to write an expression that represents all. Okay? Great. No. Then find one positive angle and one negative angle that are coterminal with each angle. So we're going to list all, and then we're going to give one positive and one negative specifically. So our expression, since every time we add 360 or subtract 360, we get a coterminal, it's just 22 degrees plus 360 degrees times that integer k, right? Because that just means we're adding or subtracting multiples of 360. If you want a positive one, just add 360. What's 22 plus 360?
382.
So there's a positive angle that's coterminal. If you want to find one that's negative, you can subtract 360. Negative 338, right? All of those 22, 382, negative 338, they're all coterminal. If I drew them all and took the spiral off, they would all look the same, right? Okay. So same thing for the other one. Negative 170 degrees plus 360 k represents all possibilities because you keep adding and subtracting. If I want a positive version, I can add 360 and get 190. If I want another negative, I would subtract 360 and get negative 530. I know it's super exciting. If they gave you like negative 380 degrees, well, you have to add 360 twice to get a positive one. It doesn't matter. Remember, k can be any integer. You can add 360 or subtract 360 as many times as you want to, and you're always going to get a coterminal angle. Questions about that? I took negative 170 and added 360. Yeah, it's negative. Okay. On this last section here, if each angle is in standard position, determine a coterminal angle that's between 0 and 360. So you're giving us constraints. Then state the quadrant in which the terminal side lies. So I have 453 degrees. I need to find the angle that's between 0 and 360 that's coterminal. So how do I do that? Subtract 360, right? You just keep to find coterminal, you just add or subtract 360. So we're going to subtract 360, and you should get 93 degrees. But I need to know the quadrant in which the terminal side lies. So 90 degrees is straight up, right? So 93 must be right past that. So what quadrant is that?
Quadrant 2.
Quadrant 2. Remember 1, 2, 3, 4. Okay. So on the next one, negative 798. I need to find a coterminal angle. So how am I going to do that? Add. Right, I'm going to add 360 until I can get something that's positive between 0 and 360. So if you do that, you should get 282 degrees. You have to add 360 twice. You have to go until you get something between 0 and 360. I gave you those constraints. So 282 degrees, this is 270. So 282 must be in here. What quadrant is that?
4.
Perfect. That's not that bad, right? So pretty much learning target 3, it boils down to coterminal angles, which is all boils down to adding and subtracting 360. Right? That's pretty much all it is. Yeah? Questions about that? All right. We have one more learning target. It seems to be that might be the most confusing today, but it's not that bad. If you would just know the definition and you could draw a picture, then you wouldn't have to worry about all the little expressions we're going to fill in. Okay, that's why I gave you the little coordinates, like the at the sides. You can draw a picture. If you can draw a picture, you'll be in much better shape. Okay. So, if alpha, so if your angle is a non-quadrantal angle, that means that the sides don't both land on an axis. In standard position, that's nice. Is reference angle is defined as the acute angle formed by the terminal side and the x-axis. All right. So I'm going to start in quadrant 2, so that because if I do quadrant 1, I think you might get confused. But it's not that bad. I just think you might get confused. So we're going to start with B. Okay. So in quadrant 2. So if I draw an angle in quadrant 2, any old angle. Right? That's my angle. Let's say that's 120 degrees. Okay? Yeah?
Yeah.
The reference angle is the acute angle formed by the terminal side, which is this side, and the x-axis. So here's the x-axis. So the reference angle is then this angle right here. Okay? We're going to be using reference angles later on learning targets 6 or 7. Okay, so the reference angle is not the angle they gave you in this quadrant, right? Acute angle formed by the terminal side and the x-axis. So what would that measure of that angle be if the purple one was 120? 60. How did you figure that out? 180 minus 120, right? Because straight across would be 180. So for B, in quadrant 2, you would always take 180 and subtract off whatever alpha is your angle measure. Does that make sense? Why I did that? 180 minus our angle measure. Our angle ended in quadrant 2. We're trying to find that little reference angle part. Does that make sense? Okay. So on C, okay, I'll go back to A. It's not hard, it's just confusing sometimes. If I have a angle that ends in quadrant 3, let's say that that's a 200-degree angle, just for ease. The reference angle is still the acute angle formed by the terminal side and the x-axis. So it's this little section right here. Follow the definition. So we have a 200-degree angle. So how am I going to find that little red section? Right, so what's this angle right here? 180, right? If I go farther, I get to my 200, so I'll just do 200 minus 180, right? And that gives me 20, so this reference angle will be 20. So we would always take our angle and subtract 180. That'll always give us our reference angle. Again, alpha is just whatever your angle measure is. My example was 200. Yes.
What is that?
It's an alpha. It just represents an angle measure. That's what our book's been using. Alpha is your degree measure.
What's that?
It's an A. It's a Greek A. You can make it X if you want to. It's just a variable representing the degree measure. That's a good question. It does look like a little fish. Again, reference angle is made by the terminal side of the angle and the x-axis. Okay, so on part D, we have an angle in the 4th quadrant. We'll say that's 300 degrees. Okay? The reference angle, again, by definition, if you know the definition, it's not that bad. The reference angle is the acute angle formed by the terminal side and the x-axis. So it has to be this angle right here. How am I going to find that amount? $360 minus your angle measure, right? That should be 0. Yes? You take the full rotation, you subtract off that little section. All right, so let's go back to A. If you have an angle in the first quadrant, we'll say it's 50 degrees. The reference angle is the acute angle formed by the terminal side and the x-axis. In quadrant 1, the reference angle is the angle. Okay? It's the same thing. Whatever your angle measure is. Okay, so if you know the definition, you shouldn't have to memorize any of these. You know the definition, you should be able to draw a picture and then find the acute angle between the terminal side and the x-axis. And then you can just figure it out, right? So 2 examples really quickly. Notice that it says on your notes, it's for any angle that's between 0 and 360. That's going to be important in a second. All right, your original angle needs to be between 0 and 360. So let's find the reference angle. 227 degrees. If I draw that, that's somewhere in there. The reference angle then is the acute angle formed by the terminal side and the x-axis. So it's this angle right here. So how do I find that?
X minus 180.
Correct. So you take the 227 and subtract 180, and you get 47 degrees. So that's the reference angle. Yeah? Now again, I just said that your original angle has to be between 0 and 360. So the last example, it's negative 210. I can draw that angle, but it's going to get tricky about doing the right math because it's negative. So we need to find a coterminal angle first. So how do I find a coterminal angle? What does learning target 3 just boil down to? Adding and subtracting 360, right? So I need to add 360 to get a coterminal angle. So I get 150 degrees. Well, I can graph that really easily. So then the reference angle is the terminal side and the x-axis. So it's this section right here. So what's the reference angle going to be? How do I find that? Right, 180 minus 150. So the reference angle is 30. Learning target 4 isn't that bad if you would just know the definition and draw a picture. If you try to memorize all the pieces, it gets a little more complicated, I think.
Why don't you go clockwise? Why do you have that? Oh, is it 0?
Yes. Yes. If not, it would be hard about picking the right math. You can't do 180 minus 210 and anything. All right.